Okay, let's unpack this. Imagine you are locked in an escape room. There are no phones allowed, no reference books, absolutely no tools to help you out.
Oh, wow. Sounds intense.
Right. Your only way out is relying entirely on how well you can apply the architecture knowledge that is, already stored in your head. And that high-pressure, closed-book environment, that is exactly what sitting for the CCA-AppDS Gateway exam feels like.
It really is the ultimate test of applied knowledge.
Yeah.
You are facing, well, 60 to 70 computer-scored questions, and exactly 10% of those are performance-based items.
Which is a pretty specific breakdown.
Yeah, exactly. You can take it in English or Japanese, but the one universal rule is absolutely zero external resources.
Yeah.
I mean, no calculators, no cheat sheets, just you and your understanding of the systems.
Which is exactly why our mission for this deep dive is to prep you with that foundational exam info and deeply analyze 5 actual practice questions. We're going to read the full text, break down every single option, A, B, C, and D, and just uncover the underlying logic. So let's start with the foundation, which is building a resilient system. Question 1.
Go through it.
Quote, which mechanism does a Citrix ADC use to determine the health of a peer node in a high availability setup? And your options are A, heartbeat messages, B, routing tables, C, authentication requests, D, SSL handshakes.
The correct answer here is A, heartbeat messages.
Okay.
Yeah, so in a high availability setup, you have 2 nodes that just must continuously monitor each other over a dedicated link. Mechanically, they send these regular heartbeats.
If those stop.
If they stop, the system immediately assumes a failure and triggers a failover. We can rule out options B, C, and D because, well, routing tables, authentication, and SSL handshakes simply do not actively monitor peer status.
Right. It makes perfect sense when you look at the mechanism. I mean, heartbeats are literally like checking a pulse to see if the machine is alive. The other options, like B, routing tables, or C, authentication, those are like checking someone's map or ID. It tells you where they are going or who they are, but definitely not if they're still breathing.
Precisely. It's an active health check.
So once our servers are alive and communicating, we need to efficiently distribute the traffic hitting them. Which brings us to question 2.
Let's hear it.
A Citrix administrator needs to configure a load balancing method that sends new client requests to the server with the fewest active transactions. Which method should the administrator choose? The options are A, round robin, B, least connection, C, source IP hash, D, least response time.
You will definitely want to go with option B, least connection.
Because of the active transactions part.
Exactly. The question specifically asks about active transactions. Least connection dynamically adapts in real time, routing traffic to whichever server is currently under the lightest load.
Makes sense.
Now, option A, round robin, is a really common trap because it is completely static. It just blindly takes turns handing out requests regardless of server strength.
Oh, well.
Yeah, and options C and D, so source IP hash and least response time, also fail because they target routing persistence and speed, not the actual transaction volume.
Okay, so the traffic is flowing smoothly, but how do we prove the people accessing these servers are who they say they are? Question 3 asks, a company wants to use a third-party identity provider for user authentication on the Citrix Gateway. Which protocol should the administrator configure to achieve this integration?
Okay.
The options are A, remote desktop protocol, B, secure shell, C, security assertion markup language, D, file transfer protocol.
The answer is C, security assertion markup language, or SAME-AL. It is, the industry standard for single sign-on.
Right.
It works by passing authentication assertions, which are basically secure vouchers, between that external identity provider and your gateway.
I have to push back a little here, though. Mechanically, why not A or B? I mean, remote desktop protocol and secure shell involve highly secure logins, right?
Well, they do involve logins, but for entirely different jobs. RDP, SSH, and FTP, which is option D, are protocols for direct remote access or file transfer to a specific machine.
So they don't do the voucher thing.
Right. They lack the mechanism to federate identity, meaning that they cannot vouch for a user across different systems the way SAME-AL does.
That clears it up. Identity federation versus direct access. Now, let's secure that connection. Question 4.
Hit me.
Where must a Citrix administrator bind the server certificate and private key to successfully terminate SSL encryption on the appliance? Options. A, on the backend, web server. B, on the client device. C, on the management interface. D, on the virtual server.
Option D is correct, on the virtual server. The virtual server is the endpoint actually handling those incoming client connections.
Gotcha.
By putting the certificate there, the appliance performs SSL offloading. It takes on the heavy mathematical lifting of decrypting the traffic, which, frees up your backend servers to just process the actual application data.
Oh, that's smart.
Yeah, so options A, B, and C are entirely incorrect interception points for terminating incoming client SSL traffic.
Okay, so we've handled the servers, the traffic, the identity, and the encryption. But what about the actual device the user is holding?
Good question.
Question 5. Which feature should a Citrix administrator use to verify if a client device has an active and updated antivirus program before granting access to the corporate network? Options are A, content switching, B, endpoint analysis, C, global server load balancing, D, application firewall.
What's fascinating here is the active nature of this process. Option B in endpoint analysis is correct.
Because it scans the device.
Yes, it actively scans the client device's posture, like checking for that updated antivirus before letting them in. Options A, C, and D are incorrect because they just manage network traffic routing or protect web applications from attacks. They do not interrogate the user's local device.
So what does this all mean for you listening at home? Mastering these concepts isn't just about passing the CCA-AppDS Gateway exam. This is the literal blueprint for building resilient, secure network environments.
Exactly. And if we connect this to the bigger picture, think about endpoint analysis verifying that antivirus software.
Yeah.
As we move toward modern zero-trust networks, what happens when the very definition of a safe device evolves faster than the strict, static policies those gateways rely on?
It's like being in that escape room, but the shape of the locks keeps changing while you are trying to solve the puzzle. Definitely something for you to ponder as you prep